By 2027, over 40% of agentic AI projects will be canceled. Enterprises are trapped in pilot fatigue. Organizations are attempting to automate broken processes instead of redesigning them, resulting in expensive, fragile overlays. Achieving operational leverage requires a shift from isolated experiments to a rigorous framework: effectiveness, enablement, and embedding. This chart shows the adoption gap. While it mandates that every AI project must be tied directly to 1 to 3 hard financial or risk KPIs. If an AI pilot lacks measurable financial or risk metrics, it must be defunded. This eliminates the stranded costs of successful experiments that can never scale. This architecture represents the enablement pillar. Fragmented systems must be standardized into a unified API layer. This standardization allows agents to operate securely from a single source of truth, using retrieval-augmented generation patterns. The final pillar is embedding. This moves agents from sidecar tools to first-class process participants. Redesigning human roles is the specific solution for algorithm aversion. When human teams and AI agents co-own service-level agreements, distrust becomes collaborative accountability. Fujitsu used this embedded approach to reduce proposal time by 60%. Contraforce automated 80% of its cybersecurity investigations. Organizations that successfully embed AI see employee satisfaction scores of 71%. At legacy companies, that figure drops to 37%. Move from theory to action. Within 48 hours, convene your executive team for a 90-minute portfolio review. Force rank every current AI project into 3 buckets: KPI tied, productivity only, or experiments with no clear metrics. Immediately freeze all spending on metricless experiments. Assign an accountable business owner to every KPI tied initiative. Stop piloting sidecar tools. Start structurally embedding AI to unlock the operational leverage your organization requires. You can spot it instantly. AI-generated text has a distinct dialect, a dense, bloated rhythm that feels artificial, even if readers cannot articulate why. Wikipedia editors identified this pattern as a threat to information quality. To track undisclosed AI content, they compiled an objective field guide of the linguistic markers used to hunt down synthetic text across the platform. A primary marker in this guide is superficial analysis. These markers co-occur with mechanical predictability, bringing structural tells like the rule of 3 or negative parallelisms, formulaic attempts to simulate insight. These repetitive linguistic tics are the exposed mathematical gears of the neural network. They show the machine functioning exactly as it was designed to. A large language model is a statistical prediction engine. It uses algorithms to guess the most likely next token based on the patterns found in its training data. This visualization shows the cost of that prediction. The model gravitates toward the safest result that applies to the widest variety of cases: regression to the mean. This central cluster represents the most average internet structures, taking the path of least mathematical resistance. Statistical gravity actively erases these specific facts. In the model's internal logic, the precise inventor of a coupling device is smoothed over and replaced by the common platitude titan of industry. Visual engines follow the same averaging logic. An undefined prompt results in flat lighting, center-weighted subjects, and a generic stock photo aesthetic. To generate professional-grade assets, the operator must forcefully override this statistical gravity through strict parameter definition. Parameter definition is the primary method of quality control. It is how we convert the AI from a generalist to a specialist. We achieve this through a foundational 4-part framework: persona, task, context, and format. Assigning an expert persona forces the model to draw from specialized data clusters, narrowing the probability space. The task and context parameters bind the scope of the output, preventing the engine from hallucinating generic summaries. Finally, the format parameter dictates the structure, forbidding the model from appending its default conclusions. Combining these 4 parameters systematically removes the machine's freedom to guess what the user wants. A fully defined prompt converts the AI from an unpredictable writer into a strictly constrained analytical tool. In visual generation, a lazy prompt like "a woman holding a product" forces the engine to guess every physical variable, from lighting to the lens. To achieve studio-quality assets, we utilize the 5-layer prompt framework to eliminate that visual guesswork. Layers 1 and 2 define the subject, action, environment, and lighting. Dictating the exact lighting direction is the only way to avoid the engine's default flat visuals. Layer 3 specifies the camera and lens. Mimicking real-world optics tricks the engine into rendering true optical depth of field instead of flat digital approximations. Layers 4 and 5 define color, texture, and style tags. These replace the plastic AI look with tactile realism and editorial-grade skin textures. Professional results require technical vocabulary. We replace subjective words like vibrant or dynamic with objective specifications for light, optics, and surface texture. Treating the AI as mechanical studio hardware guarantees consistent, high-fidelity results that general prompts cannot achieve. Even with strict structural parameters, an LLM will attempt to inject its default conversational habits unless explicitly told otherwise. We counter this with the Dieter-Rams system prompt, an operating framework based on the industrial design philosophy of less but better. Under the rule of restraint and neutrality, the AI must act as a utility. It is instructed to strip out introductory pleasantries, emojis, and enthusiastic affirmations. We achieve this by applying negative constraints, explicitly banning the AI's most frequent statistical behaviors. We ban the overrepresented vocabulary. Forbidding words like delve, tapestry, and foster forces the neural network to route around its most heavily worn statistical pathways. We also ban syntactic crutches. The model is forbidden from using the rule of 3 or trying to simulate insight through negative parallelisms. We enforce the use of basic, direct verbs like is or are. This stops the model from using bloated replacements like serves as, identified in the Wikipedia guide. The Dieter-Rams protocol reconfigures the model's logic tree, prioritizing absolute, unapologetic clarity over the simulation of human politeness. A rapid A/B comparison demonstrates how these engineered constraints transform the final output. We begin by feeding the complex history of the Panama Canal into a default, unconstrained prompt. The model relies on generic summaries and not just X but Y structures. It fails to process raw data, opting for a formulaic conclusion starting with, despite its success. We run the exact same historical data through the 4-part framework and the Dieter-Rams system prompt. The new output is stripped of conversational filler. It uses basic verbs and a dense delivery that aligns perfectly with the technical evidence. We apply the same test to visual generation, starting with the flat, center-weighted baseline from a lazy prompt. We contrast that with the 5-layer framework. By defining the lens and the light direction, we achieve tactile realism and professional-grade fidelity. The difference between a generic output and an enterprise-grade asset lies entirely in the operator's ability to command the system's variables. Neural networks are not creative partners. They are vast mathematical probability spaces. Leaving operational parameters undefined is an invitation for the machine to provide the most statistically average result. Mastery of artificial intelligence requires abandoning the illusion of magic and applying engineering precision. By explicitly defining every variable, we force the machine out of its default mediocrity and into specialized performance. Building a trusted brand through AI requires a shift in perspective. You must treat the engine as a piece of hardware and explicitly forbid it from being average.